Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azim bin Muhammad Azari. My metric number is 1712167, and today I'm going to presenting about my final year project 2 with a title of Assessment of Sungai Pusu Water Quality using GIS, or known as Geographical Information System. Therefore, my presentation start with the presentation outline, where I will firstly explain about the introduction and then continue with literature review, methodology, result and discussion, and lastly I will explain about the conclusion. Okay, first and foremost I will explain about the introduction of this this FYP, where the first is about the problem statement, where the first problem statement is Sungai Pusu have significant content of sediments and turbidity due to the high sediment and turbidity that causing the water or river become cloudy in color and also dirty, and also due to the sand mining activities that occurs outside the boundary of IUM. And next problem statement is that high value of COD during rainy days also affect the poor quality of Pusu River. Next, I will proceed with the objective of this research, where the first objective is to determine the class of the Sungai Pusu using water quality index method, and then to apply the application of GIS in helping with the water quality assessment of Sungai Pusu in order to identify the polluted rates of each unsampled location for each parameter. And lastly is to make a comparison between two mapping methods of spatial interpolation in ArcGIS software, which is ordinary Kriging method and also the inverse distinct weight method. Next, I will proceed with the literature review, where for this literature review I will do a comparison between the GIS and also the water quality index about when I do the research, where the first comparison is that data or result sample from lab test for GIS is stored in the software, while for the WQI, data or result from the sample will be used for calculation. The next difference is that GIS or Geographical Information System is used for the to generate map, while the WQI is for the calculation of WQI. While for next the comparison is that GIS can identify which location have higher or lower concentration of water quality parameter, while for WQI it can identify the class of the river in each location or sample. And lastly, the main difference for the comparison is that GIS is a software or system, while for water quality index is the method. Next, I will proceed with the methodology of the research. So I will follow the flow. I will show you the flowchart here. That firstly, the method of this research start with the data or result of lab tests are taken from the previous semester to use in this research project. The data are taken provided is resulted of 6 main water quality parameters such as BOD, COD, DO, pH, TSS, and also the ammoniacal nitrogen in 2019. For the data of 2017, it is the five main water parameter again, except only the COD value are not given in this data of 2017. Well, and then continue with the flowchart that can be seen that data of 2018 will be used for the WQI calculation, as the 6 main water parameters are complete to use in WQI formula, where the method is start with firstly calculate the formula for the sub index, and also we can, after we calculate for the formula of the snap, we can finally compute the WQI value for each sample location. Then following the table of class classification of the class of river, we can identify the class for each location sample, and overall we can make a conclusion about the Pusu River about the class of Pusu River in 2090 will be determined. So this is an example of the table for the sub-index formula for equation for the left table, and then in the right table is the table of class classification of the table classification of the water quality index. Back to the flowchart. For the generated map in flowchart, the method start with both data in 2017 and 2019 will be stored in the Excel software first with the coordinates of latitude and longitude of sample location taken from Google Earth Pro. So this is an example where the left is the data of 2019 with coordinates of latitude and longitude from Google Earth Pro, and beside that is the parameter of the data of 2017 with coordinates of latitude and longitude of location sample taken from Google Earth Pro. Back to the flowchart where, so after taking the data and store in the Excel software, we then combine the data. And import it to ArcGIS software, specifically ArcMap, together with the shapefile of Sungai Pusu study area that also taken from the Google Earth Pro. It can be seen here, the shapefile of study area of location of sample taken from the Google Earth Pro. Next, after that, we go back to the flowchart. Then, after all data are updated in the ArcGIS, step by step were done to special interpolate the map on the two methods of IDW and ordinary kriging in ArcMap. Then continue with the first few steps are the same for each method, like clicking and undergo the geoprocessing method, environment settings, and raster analysis. The difference only start when further go to the out toolbox, where for the IDW need to click IDW, while ordinary kriging need to click the kriging. So this is an example of out toolbox that can be seen here. And then other few steps were done after we click in the out toolbox, where continue with the step on choosing the Z value for each parameter in order to generate the map, and then map are simulated according to the parameter chosen, and formula that may run according to each of their own method. When the map are fully simulated, edit of the symbology for its range and label for the map also been through successfully complete, and the final simulation of each map are simulated. Then after finish all the generated map, we continue with the next method is comparison between the two methods of mapping in terms of performance using the mean square error, root mean square error, mean absolute error, and mean absolute percent error, where every method have its own formula or equation that need to be followed in order to make sure the calculations are calculated correctly for reference. Next, and after that, the conclusion can be made in which method are most suitable for this research. Next, I will proceed with the result and discussion of this research, where based on the slide, it can be seen that all sub-index are fully calculated and WQL for each location sample have been determined. And it can be seen also from the calculation above. It shows that Sungai Pusu is mainly in class 3, as majority of sample location is in class 3, while only location of T5 achieve class 2 from this calculation. Therefore, the final question is Pusu River is in class 3 on 2019. Next is the result for the generated map of spatial interpolation of IDW for each water parameter data in 2019. So it can be seen here there is a map of ammoniacal nitrogen, BOD, COD, DO, pH, TIS. And next is the result of generated map for a spatial interpolation of IDW in 2017. That's like the same, is a different map with a different data. Is got AN, BOD, DO, pH, and also TIS, except COD due to no presence of data of COD. So for explanation of this IDW generated map result, it shows that the generated map of spatial interpolation of IDW method for both year in 2019 and 2017 are successfully simulated. And based on all of the maps in both here, it can shows that or seen that the range of class for each range in each map are tally with the result of interpolation for each unsampled location, and the concentration of each water quality parameter can easily be detected to assess the pollution rate or know the concentration of each water quality parameter of Sungai Pusu in those unsampled location. So, for example, the example of the total suspended solely in IDW map of 2017, we can be seen that for location T5 with the value 26 tally with the range of its color, where the yellow range where it is in range of class 1, where the range is between 22 until 30.338. So you can be seen that the results are correct and all interpolated map on each parameter of IDW correlate with the color of each class. Therefore, it also can be seen that no errors are identified in using this IDW method with this data value. Next is the result or generator of special interpolation for ordinary kriging. As you can see, it's all map of ordinary kriging in 2019. And next is the result generated map or special interpolation for each water parameter in data in 2017. That is got AN, VOD, DO, total dissolved solid, pH, and so on. For the explanation of ordinary kriging generated map result, it shows that generated map or special interpolation of ordinary kriging method for both year of 2019 and 2017 are completely simulated. However, as compared to IDW, there are errors occur or identified majorly on each map or special interpolation of ordinary kriging method. The error is the value of range in each class of both year of are not tally with the value of concentration for each parameter in map except the map pH of ordinary kriging in 2017. So it can be seen here where the example of total suspended solid in 2017, where the location T1, which is mainly in class 1, the value actually is 22, but the range of class 1 start with 32, which is really wrong. It means that errors are occurs. So it means that interpolation for this map have the error that should not have done. So it also happen on each map of this kriging except only pH. So the reason for this is called the ordinary kriging variant fail due to the independent data values. This independent data occurs due to the big gap or very different in values between the surroundings or nearby data. One of the researchers also stated in a place surrounded by data that are substantially different from one another, the possibility for prediction error is likely to be higher than at a place surrounded by similarly valued data. This causes the ordinary kriging variance cannot recognize this and cause errors of interpolation. And it was also added that the independent data values are considered as bad feature, where the data is not in normal distribution. The data that is not in normal distribution also in fact that they are not spatially correlated to each other. This shows that the data are neither in positive autocorrelation nor negative autocorrelation, where the positive autocorrelation is when the nearby data values are similar to each other, while negative autocorrelation is when nearby data are less similar. They also explain why the pH ordinary kriging map in 2070 is the only one that is error-free and inside the range, as the value of the data from each other are spatially connected with only the difference in value between them. Next, I will explain about the result of MSE and root mean square error, and then the mean absolute error and also mean absolute percent error. So based on the table above, it can be observed that there is only slight difference in value between the two spatial interpolation method, where overall it shows that ordinary kriging has most slight errors for each method of error calculation in year of 2017 and 2019, and due to the difference is very small, and there are also some errors in certain parameter in IDW in the method are less than ordinary kriging, it can conclude that the performance of these two methods is similar for this research. Therefore, due to the errors that occur in ordinary kriging and its limitation, we can say that for this research, IDW method or inverse distance weight method is more suitable for this research. Lastly is the for conclusion. It can be seen that conclusion all reality are fully achieved, calculation of WQI also determined, and application of GIS also successfully used to help generate the spatial interpolation map. And lastly, IDW method are more suitable as compared to ordinary kriging method due to the data values and limitation of ordinary kriging. And lastly, I will explain about the recommendation. For the first recommendation is different type of method of spatial interpolation IDW or ordinary kriging can be used. Different point source of pollution at Pusu River can be used for water quality assessment to get different values of data that correlate to each other. And lastly is the we can add other method of error calculation to differentiate the performance of method of spatial interpolation in order to enhance more the result in future to get a better result. Okay, that's all from me. Thank you.